Assalamualaikum warahmatullahi wabarakatuh. So my group will present on our assignment presentation for Software Secure Development subject. Our teams are Mohamad NAZMI, myself Nur AFIQAH, and SITI SABRINA ALHABSHEE.
Hello, Assalamualaikum. My name is Mohamad bin AZAHARI and I am presenting number one, lack of input validation of untrusted user input. So the first one is type of the vulnerability in computer software that may be used for security exploits. So the product does not validate and incorrectly validate input that can affect the control flow or data flow of a program. So improper input validation can cause buffer overflow, cross-site scripting, directory traversal, null byte injection, SQL injection, and uncontrolled format string. So for the example, as we can see, the expression using the expression variables. Expression coding, type of coding. So we're using the whitelisting. So this is the define what character are acceptable, such as A to Z with the uppercase, A to Z for the lowercase, and 0 to 9, and it filter out everything else in validation code. This is called filtering code. So as you can see in the code, we're using the expression to perform the email address input. So we're using the prep match to perform a regex data verifier. The $sign regex to perform a regex data verifier. So the second one is this is the table, which is the use the A to Z for the simple. So this is the all lowercase letter in the range from letter A to Z. So using the letter and number 8, we plus 0 to 9, yes, and then format for MD5 hash, and then we got Mastercard format and Visa credit card format. And then this is the other simple coding, which is use the range, medium range 15 to maximum range 20. So this is the specific quantities such as value for the size, length, frequency, price, rate, number of operation, time, etc. So the second one is logical error. A logical error is a mistake in the program source code that result in incorrect or unexpected behavior. It is a type of runtime error that may simply produce the wrong output or may cause a program to crash while running. So for example, as you can see in the coding, so this is the wrong type of coding. It uses the if statement, which is the sign $I equal to 1. So this is wrong because I equal to 1 is the static variable. It declared a static variable. So the correct one is if statement coding. So it declare the sign $I double equal to 1. So in PHP, double equal means equal to, while equal means becomes. The incorrect if statement always return true, since the assigning one to variable $i returns a true value. In the correct code, the if statement only returns true if sign $i is equal to 1. Hence, it will not produce a syntax error and the code will be compiled successfully. So the third one is web browser plugin tracks. Browser extension allow users to customize their web browser for convenience, efficiency, and even privacy and security. Usually, it is for free software, for free plugins. These innate vulnerabilities, along with their popularity, make browser extension a very attractive target for cyber criminals. And sometimes, hackers don't bother coding their own extension. They just hijack legitimate one by takeover of a popular extension legitimately and purchase it from the developer, add malicious code and push and update through. So for example, this is the case, one of the case of Google Chrome. This is reported by a Medium blogger, which is Google Chrome had a case on their extension called CCB Cache, which is purported to give user up to 5% cashback on of their cryptocurrency transaction. In actuality, CCB Cache did nothing but steal login credentials and cryptocurrency. So Google has since removed CCB Cache from its extension store, but not before the hacker behind it managed to make off up to a little over 81 million. So this is the number 4, JavaScript enabled browser threat. So it can be abused that leads to scenarios that make it possible to snoop on your internet activity and violate your privacy. So there is 3 ways. There is 3 ways JavaScript can breach your privacy and security. For the first one, snooping the words you type. The second, tracking your browser habits, and malicious code injection. So I think that's it for me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is AFIQAH, and I will continue from here. So number 5, least privilege technique. The definition is that it is the concept and practice of restricting access rights for users, accounts, and computing processes to only those resources absolutely required to perform routine, legitimate activities. We know that privilege itself refers to the authorization to bypass certain security restraints. Applied to people, least privilege, sometimes called the principle of least privilege or POLP, means enforcing the minimal level of user rights or lowest clearance level that allows the user to perform his or her role. However, least privilege also applies to processes, applications, systems, and devices such as IoT, in that each should have only those permissions required to perform an authorized activity. Basically, least privilege is intended to prevent over-privileged access by users, applications, or services to help reduce the risk of exploitation without impacting productivity or involving the IT help desk. For example, super user accounts. It is primarily used for administration by specialized IT employees, may have virtually unlimited privileges or carte blanche over a system. Super users account privileges can include full read, write, execute privilege, and the power to render systematic changes across a network, such as creating or installing files or software, modifying files and settings, and deleting users. Standard user accounts, sometimes called least privileged user accounts, LUA, or non-privileged accounts, have a limited set of privilege. In a least privileged environment, these are the type of accounts that most users should be operating in 90 to 100% of the time. Next, we'll move to sandboxing techniques for iframes. Using an iframe with content from a different domain embedded into a site triggers a browser's cross-domain policies, which maintains a separation between your code and the iframe's content, basically preventing it from accessing your DOM, cookies, or local storage. However, even with these automatic cross-site protections, an iframe elements from a different domain still can autoplay videos, display forms, even trigger alerts, run plugins, including those malicious ones, and also allow unwanted pop-ups. We do not want iframes to be able to interact with our own web pages to this degree, or to be honest, any degree at all. This can allow for iframe security issues and risk that could have severe consequences. Thankfully, a solution to this was developed called the Sandbox attribute, first made available on Internet Explorer 10. Inserting the Sandbox attribute secures an iframe even more sturdily, ensuring that the documents within the iframe cannot submit forms, change the parent web page's URL, run plugins, read cookies or local storage even if it's from the parent domain, open new tabs, new windows or pop-up windows, even running any JavaScript, even if it would only impact what's inside the frame. This sandbox attributes of the iframe element gives us what we need to tighten the restrictions on frame content. We can instruct the browser to load a specific frame's content in a low privilege environment, allowing only the subset of capabilities necessary to do whatever work it needs doing. So as you can see, the code above is a button that Twitter allows you to embed the button via an iframe. So we'll examine what capabilities the button requires of it. The HTML that's loaded into the frame executes a bit of JavaScript from Twitter servers and generates a pop-up populated with the tweeting interface when clicked. The interface needs access to Twitter's cookies in order to tie the tweet to the correct account and needs the ability to submit the tweeting form. That's pretty much it. The frame doesn't need a load of plugins. It doesn't need to navigate a top-level window or any of a number of other bits of functionality. Since it doesn't need those privileges, let's remove them by sandboxing the frame content. So sandboxing works on the basis of a whitelist. We begin by removing all permission possible, and then turn individual capabilities back on by adding specific flags to sandbox configuration. So for the Twitter widget, we've decided to enable JavaScript, pop-up, from submission, and twitter.com cookies. We can do so by adding a sandbox attribute to the iframe with the following value. We've given the iframe all the capabilities it requires, and the browser will helpfully deny it access to any of the privileges that didn't explicitly grant it via the sandbox attribute value. As you can see, the iframe sandbox equals to all same origin, allow scripts, allow pop-ups, allow forms. Next, let's look at secure failing handling. It's not unusual for web applications or database to generate error messages. In fact, they are a normal part of operations and they provide valuable insights into issues and problems. However, improper error handling introduces significant security risk. So when a system fails, it should do securely. This typically involves several things. Secure defaults. Default is to deny access, unfairly undo changes, and restore to a secure state. Always check return value for failure, and in conditional code or filters, make sure that there is a default case that does the right thing. For example, the confidentiality and integrity of a system should remain even though availability has been lost. Attackers must not be permitted to gain access rights to privileged objects. Attackers must not be permitted to gain access rights to privileged objects during a failure that are normally inaccessible. Upon failing, a system that reveals sensitive information about the failure to potential attackers could supply additional knowledge for creating an attack. So basically, we should determine what may occur when a system fails and be sure it does not threaten the system. For example, here in this code, if code which may fail fails, the user is an admin by default. This is obviously a security risk. The fix is simple. In this case, it involves a simple reversing of the logic. So as you can see here in this code, if code which may fail requires admin access, we should be verifying the admin access before we run that code. This example is also an example of the least privilege principle, which states you should never grant more access than required. Next, mixing data and code security issues. Data is information that your CPU acts on, and code basically tells your CPU to take action. These days, data and code are intermixed, such as ELF, EXE, HTML, or doc. So why developers does it? So first, it's cool. It is dynamic, interactive environments such as HTML. It can also be flexible. It has an extended functionality like doc. It is also efficient. It can be a flexible software building blocks, for example, .js. Lastly, it also has market shares where the features increase usage. Mixing data and code is a mixing of two or more languages. Mixing of data and code can cause problems. For example, buffer overflow attacks. This attack relies on a mixing of data and code on the stack, namely data and return address on the stack. Virtual basic scripts in the Office documents. This could lead to attacks by hostile.doc or XLS. Lastly, JavaScript in web pages. This could also lead to cross-site scripting attacks. That is all from me. Thank you.
Okay, so Assalamualaikum. My name is Sabrina. So I'll be continuing with number 9, which is code-based access control. So what is access control first of all? Access control is a security technique that regulates who or what can view or use resources in a computing environment. So it means that who can use or do what in the computing environment. It's a fundamental concept in a security that maintains risk. So what is needed in CBAC are as follows. The first one is permissions, the second is components, and the third is policies. So permission is the right to do a particular thing, and then policy is a permission that is given to the component. So it means that who is allowed to do what. Okay, so the next slide. Number 10 is memory safety. What is memory safety? Memory safety is the state of being protected from various software bugs and security vulnerabilities. So it is said that Java is memory safe because its runtime error detection checks array bounds and pointed dereferences. So the example of types of memory errors are as follows. In terms of access errors, there are buffer overread, buffer overflow, race conditions, as well as use after free. So what is buffer overread? Buffer overread is out-of-bound reads that can reveal sensitive data. Buffer overflow is out-of-bound writes that can corrupt the content of adjacent objects. Race conditions is concurrent reads or writes to share memory. Use after free is dereferencing a dangling pointer storing the address of an integer that has been deleted. So in terms of memory leak, what does it mean? It means that when memory usage is not tracked or it's incorrectly tracked. Okay, there are 3 in terms of memory leak. There's stack exhaustion, heap exhaustion, and double free. In terms of stack exhaustion, it occurs when a program runs out of stack space, and then when it runs out of stack space, the guard will typically halt the program. It means it will stop the program to prevent memory corruptions, but functions with large stack frames may bypass the page. So in terms of heap exhaustion, the program will try to allocate more memory than the amount available. So if let's say it can only enter up to 20 program at a time, let's say for example, it will do more than 20. Okay, so that's what it means. So double free is repeated calls to may prematurely free a new object at the same address. If the exact address has not been reused, other corruption may occur, especially in allocators that use free list. Next. Number 11 is type safety. Type safety is the extent to which a programming language discourages or prevents type errors. So what this typically means is that the compiler will validate types while compiling and then throw an error if you try to assign the wrong type to a variable. Okay, so what does type error means? So type safety prevents type errors. So what does type error means? Type error is a erroneous or undesirable program behavior caused by a discrepancy between differing data types from the program's constants, variable, and methods. So, for example, treating an integer as a floating point number. So we'll see a very simple coding. This is a very simple coding. It shows that the integer being assigned to type string, which is wrong. So we'll move on to the next one, which is number 12. The last one is threads safety. So typically Java supports multi-threading. This means that by running bytecode concurrently in separate worker threads, the Java virtual machine can improve application performance. Although multi-threading is a powerful feature, it comes at a price. In that multi-threading environment, we need to write implementations in a thread-safe way. This means that different threads can access the same resource without exposing erroneous behavior or providing unpredictable results. That's what thread safety is. So there are two approaches to thread safety. The first one being stateless implementation, and the second one is immutable implementations. So in stateless implementation, in most cases, errors in multi-threaded applications are the result of incorrectly sharing state between several threads. So to better understand this, we will see the coding. So the factorial method is a stateless deterministic function. Given a specific input, it will always produce the same output. The method neither relies on external state nor maintains state at all. So all threads can safely call the factorial method and will get the expected result. So actually, stateless implementations is a very simplest way to achieve thread safety. So the second approach would be immutable implementation. Okay, in this approach, we need to share state between different threads. So if we need to share state between different threads, we can create thread safe classes by making them immutable. So how do we do this? Is by simply by declaring all the fields private and final, and by not providing setters. So the message service effectively immutable since its state can't change after its construction. Hence, it's thread safe. Moreover, if message service mutable, it's already mutable, but multiple threads only have read-only access to it. It's thread safe as well. So, having said that, immutability is just another way to achieve thread safety. So that's all. Thank you very much.